Imagine stepping into a gaming world where every single non-player character, every NPC you encounter, isn't just, a static background element
Right.
or a predictable quest giver just cycling through the same 5 lines of dialogue over and over.
Oh, yeah, the worst.
Instead, picture them as dynamic, unpredictable beings, almost as real and complex as someone you'd meet just walking down the street. No more broken immersion, no more routines that just pull you right out of the experience.
And that sounds like the dream, doesn't it?
Well, that vision, which maybe once felt like distant sci-fi stuff, it's rapidly becoming our reality. Today on the Deep Dive, we're really embarking on a mission to explore exactly how artificial intelligence is being used to craft these truly intelligent, dynamic, and, well, believable NPC behaviors in modern gaming.
It's a huge shift.
It feels like a revolution in digital minds, and it's fundamentally changing everything we thought we knew about virtual worlds.
That's absolutely right. And the ambition here, it really goes far beyond just, polishing graphics or adding more lines of dialogue, although those things are important too, of course.
Sure.
It's really about a fundamental shift in how we interact with virtual worlds. We're transforming what were once, like you said, mere background elements into complex, engaging entities that can genuinely surprise you.
Entities that can adapt.
Exactly. Adapt to you and maybe even remember your past interactions. We're moving way beyond pre-scripted interactions to something far more alive and responsive.
Okay, and to help us unpack this fascinating revolution, we're drawing from a really rich stack of sources today. We've got deep dives from academic research papers, specifically looking at the International Journal of Computer Engineering in Research Trends.
Right.
We've got papers spanning from 2016 up to a very recent one from 2024, including a really fascinating look at how combat NPCs are actually modeling stress.
Yeah, that stress paper is super interesting. We'll definitely dig into that. And we'll also be pulling crucial insights from a recent YouTube deep dive that looked into some really cutting-edge AI agents, exploring some genuinely groundbreaking work. Plus, we'll be drawing on, real-world discussions from game developers on platforms like Reddit, which gives us a direct pulse on what's happening on the ground.
Kind of the practical side.
Exactly. And also valuable industry analyses from firms like Naavik and GopenAI with their perspectives from 2024 and even looking into 2025. So our mission for you, the listener, is basically to extract the most important nuggets of knowledge and insight from all these diverse perspectives.
That's a shortcut.
Yeah, kind of a shortcut to being truly well-informed about these really complex advancements that are shaping the future of virtual interactions.
So prepare for some genuine aha moments, maybe some surprising facts, and hopefully just enough humor to keep you hooked as we delve into this truly groundbreaking transformation. We're not just uncovering what is happening in this space, but critically, why it matters for your gaming experiences, and frankly, maybe the wider world of digital interaction too. Let's jump in.
Okay, listen to me start at the very beginning, kind of trace the lineage of our digital companions. For the longest time, the non-player character, the NPC, was essentially what I sometimes call a cardboard cutout.
Hey, yeah, that's a good way to put it.
Anyone remember the guards in older RPGs, the ones who would greet you with the exact same pre-recorded, often totally monotone phrase every single time you walk past, no matter what you've just done?
Oh, absolutely. Hail, adventurer, for the 100th time.
Exactly. Or enemies who followed incredibly simple, like repetitive attack patterns that you could just memorize and exploit in minutes, turning what should be epic boss fights into these predictable choreographies.
Yeah, that was the reality for so many years. And if we look behind the curtain, in those early days, NPCs were primarily governed by what we call simple rule-based systems and finite state machines, or FSMs for short. Okay, FSMs, so that's like a very basic set of rules.
Exactly. Think of an FSM as a very rigid set of instructions, almost like a flowchart with Boolean logic, if this, then that. An NPC can only exist in one finite state at any given time.
Like idle or patrolling.
Precisely. A guard might be in an idle state, then transition to a patrolling state along a fixed path, and if they spot you, boom, switch immediately to an attacking state.
And the switch is just based on a simple trigger.
Right. The transitions between these states were strictly defined by really simple conditions. If X happens, then do Y. This just made their behaviors highly predictable and inherently limited in community. Players quickly learned their patterns, right?
Yeah.
And that predictability often just shattered the immersion, pulling you right out of the fantasy.
And for a truly rich gaming experience, why was that such a problem? I mean, aside from being boring.
Well, it reduced NPCs to little more than passive components in the environment, or, like you said, digital punching bags.
Right.
They weren't actual alive elements that contributed to a believable breathing world.
You just knew, didn't you? Almost instinctively that you were dealing with lines of code, not a character with any kind of agency or genuine presence.
Yeah, it's hard to get invested in a world that feels so, well, so scripted.
Right.
And if we connect this to the bigger picture, historically, the very earliest computer games had virtually no AI at all. Games like Tennis for Two back in 1958 or Space War on the PDP-1 mainframe, they didn't feature computer-controlled opponents. They were strictly two-player.
Oh, okay.
Even when AI did start to appear, mainly in early arcade games like Pong, Space Invaders, Donkey Kong, it was incredibly rudimentary.
Like the ghosts in Pac-Man.
Exactly. Those agents operated under terribly easy rules and heavily scripted actions. The ghosts followed simple pursuit and scatter patterns. They just didn't have the flexibility to make independent selections or adapt in any meaningful way.
So how did they make it feel unpredictable?
Often, developers just resorted to adding randomness like a dice roll here or there just to simulate unpredictability, to give the player a tiny illusion of a thinking opponent. But the intelligence, quote-unquote, was hard-coded, not emergent.
Gotcha.
So while the golden era of arcade games, 1978 to the early 80s, saw immense profits and huge cultural impact, the underlying AI was still very, very basic.
Even later, with 3D graphics.
Yeah, even with the massive transition to 3D games in the 1990s, where the graphical leaps were just astounding, much of the development effort still went into visuals. AI advancements often progressed in smaller, kind of incremental steps. It lagged behind the graphics for a long time.
So despite all those incredible leaps in graphical fidelity in the 90s and beyond, what really catalyzed this push for smarter AI, it sounds like there was maybe a growing dissatisfaction, like an unspoken demand from gamers.
I think that's right.
Because the worlds looked stunning, but the fundamental interactions with the computer-controlled elements, they often remained largely the same. Beautiful, sprawling worlds, but kind of static, almost lifeless inhabitants.
That growing dissatisfaction truly spurred a fundamental shift in mindset within the industry. Developers began to recognize that NPCs play an absolutely critical role, not just in the functional operation of the game, providing quests, selling items, reacting in combat.
The mechanics.
Right, the mechanics, but also, perhaps more importantly, in its overall feel and, critically, its gameplay. How immersive is it? How surprising.
Makes sense.
This recognition led to an intensified quest for more believable and immersive NPCs. And in this specific gaming context, when we talk about AI, we're not necessarily talking about, consciousness or sentient beings. That's not the goal, usually.
Right, not Skynet.
Not Skynet, hopefully. Instead, it's defined as, and I'm quoting directly from one of our sources here, a code of block or thread or process that runs in the background of the application and provides a support or help to its components to work smarter or for human-like decision-making or interactions.
Okay, so human-like.
Yeah, the core purpose is really just to create the illusion of intelligence in these computer-controlled agents, making them feel real to you, the player.
So this isn't just a technical upgrade. It's really about fundamentally transforming the player experience. It spurred this quest for more believable and immersive NPCs, recognizing that these characters play an important role in operating as well as performance of the game and significantly impact the feel and therefore the gameplay.
Absolutely.
It's about moving from just rendering incredible visuals to crafting a living, breathing, interactive world, isn't it?
Exactly. And to pinpoint a major catalyst, role-playing games, RPGs, were a huge driving force for AI advancement in games.
Ah, okay. Why RPGs specifically?
Well, their very nature demanded highly competent and entertaining AI. Players in RPGs expected dynamic characters that could perform well, effectively, and interestingly. They needed to respond to player choices, maybe remember past interactions, contribute to the narrative in meaningful ways.
Like a companion character.
Right. Think about a companion character in an RPG.
Yeah.
You want them to feel like a true ally, not just a script following you around, occasionally spouting a generic line.
Yeah, you want them to have some personality, react to things.
Precisely. This inherent demand from the RPG genre created a vital need for more sophisticated AI techniques that could handle complex scenarios and, importantly, long-term consequences.
Okay, now that brings us to the exciting part. How do developers actually give NPCs these smarter, more dynamic brains that go far beyond those simple, predictable state machines we talked about? What are the evolving techniques they're using now?
Yeah, it's been a really fascinating progression, building upon those foundational FSMs, but making them much more capable. First, we have behavior trees, or BTs.
Behavior trees.
You can think of these as a much more sophisticated kind of FSM, offering far more flexibility. Instead of just a flat list of states, BTs decompose NPC actions into hierarchical nodes, almost like a decision tree.
So more layers of decision-making.
Exactly. This allows for much more intricate decision-making and gives NPCs the flexibility to react dynamically to changes in the environment. So instead of just, if enemy seen, attack, a behavior tree might allow for, if enemy seen, check cover, then check ammo, then decide best attack strategy. More steps, more nuance.
Right. Much smarter.
It's actually known that designers for games like Halo, with its famously intelligent Covenant and UNSC AI, used a form of behavior tree.
Oh, really? Halo?
Yeah, to create their adaptive AI. That's how you get grunts fleeing when their elite leader falls, or elites flanking and suppressing the player. That's behavior trees at work.
Okay, that makes sense. What else is in the toolkit?
Then there are hierarchical task networks, or HTNs. This offers an alternative, highly structured planning approach.
HTNs. How are they different?
With HTNs, compound high-level tasks, like, say, clear a building, are broken down into subtasks, which are then broken down further into primitive actions the NPC can actually perform.
So like a plan within a plan.
Pretty much.
Yeah.
Clear a building might become secure ground floor, then move upstairs, then clear second floor. And each of those might involve find cover, suppress enemy, move forward. HTNs explicitly describe methods to achieve goals.
Ah, okay.
This provides immense advantages in planning and scripting complex, multi-step sequences of actions that feel genuinely purposeful.
So the NPC isn't just reacting, it's following a plan.
Exactly. Imagine an enemy not just reacting to you in the moment, but systematically clearing a building to corner you, even if you're out of sight for a bit. That's a fundamental shift from purely reactive to proactive, goal-driven AI. It makes enemies feel less like a collection of scripts and more like, well, sentient adversaries with a bigger strategy.
Okay, that's a big leap. What else?
And we also have goal-oriented action planning, or GOAP. This was famously developed for the game No One Lives Forever 2, way back in 2002. And it really changed how some AI was approached.
GOAP. Okay, how does that one work?
GOAP specifies how decisions are taken based on 4 key concepts. First, an action. A step performed by the agent, which can have preconditions what must be true before the action and affects what changes after the action.
Like open door requires be at door and results in doors open.
Precisely.
Yeah.
Then there's a plan, which is just a sequence of these actions designed to achieve something. Third is the goal, the desired state the NPC wants to achieve, maybe find weapon or heal ally.
The objective.
Right. And finally, a planner. This is the algorithm that takes the most relevant goal and dynamically creates a plan, that sequence of actions to go from the current state to the desired goal state.
So it figures out the steps itself?
Yes. The genius here is that the planner is actually quite similar to pathfinding algorithms like A, but instead of finding the shortest physical path, it finds the most efficient sequence of actions to achieve a goal. It lets NPCs essentially figure out how to do something on the fly, rather than being told every single step in a rigid script.
Okay, BTs, HTNs, GOAP. Those sound like significant improvements. But now, here's where it gets really interesting, right? Where the future of NPC behavior truly seems to lie. Beyond these more structured planning approaches, the true game changer, the thing that's pushing the boundaries the most, is machine learning. This feels like a completely different paradigm.
Oh, absolutely. Machine learning enables NPCs to actually learn from player actions over time and modify their behavior in much more individualized ways.
Yeah.
This is a fundamental shift from static scripts, where every NPC largely behaves the same way every time, to adaptive behaviors that actually evolve during gameplay.
How does that work in practice?
Well, for example, reinforcement learning, RL, allows NPCs to learn optimal behavior through trial and error. Imagine an enemy NPC who starts adjusting its attack patterns based on your specific combat style.
Like if I always dodge left.
It might start anticipating that and aiming where you're going to be, not where you are. Or think of a friendly companion who learns the types of spells you prefer to cast and then proactively provides the mana or support you need for those spells without you even asking.
Wow.
This creates truly emergent gameplay that keeps players on their toes, because the AI isn't just following a pre-written script, it's actively learning to counter you or support you in real time. It moves from predictable challenges to unique, evolving ones based on how you play.
That sounds amazing. And then there's deep learning.
Right. Then we have deep learning, DL, which is a powerful subset of machine learning. Deep learning uses neural networks with multiple layers, hence deep, to process incredibly complex, unstructured data. Think images, sounds, raw text, stuff that traditional algorithms struggle with.
And it finds patterns.
Exactly. It recognizes intricate patterns within that data. This enables NPCs to perform really advanced tasks like nuanced speech recognition, analyze facial expressions or body language to infer emotions, and make real-time decisions with incredibly high accuracy based on all this dynamic input.
So they can understand more subtle things.
Yes, it transforms NPCs from purely static entities into truly dynamic participants within the game world, capable of nuanced and intelligent responses that feel genuinely human-like. Imagine an NPC companion recognizing the frustration in your voice, maybe seeing your character's slumped posture and offering words of encouragement or a relevant strategic suggestion. That's the kind of thing deep learning enables.
It's frankly mind-blowing to think about. Characters that aren't just following a script, but are actually learning from how you play, adapting to your strategies, responding in ways you couldn't possibly predict. So the key insight here is we're moving from AI that merely responds to AI that learns and predicts. That's a massive leap in immersion and replayability.
Absolutely.
Yeah.
And a prime, cutting-edge example of AI's next stage, what some are calling a fundamental brain upgrade for game characters, is something called Language Agent Roleplay for Open World Games, or LRP.
LRP.
It's designed specifically to help these game characters remember things better, make smarter decisions, and interact much more realistically with the game world. It's kind of like teaching them how to learn from what happens in the game, process those experiences, and then use that knowledge to act more like real people, complete with unique quirks, memories, and motivations.
So what exactly makes LRP so special? It sounds like it goes deeper than just enabling smarter decision-making. It's not just about logical choices, is it?
It certainly does. LRP's core features enable NPCs to have vastly diverse personalities and backgrounds. This makes them way more interesting and unique. Imagine a cautious shopkeeper versus an audacious adventurer. LRP allows these fundamental differences to really shape behavior beyond just their dialogue lines.
So their personality affects their actions.
Definitely. Some characters might be inherently brave, while others are cautious, leading to much more fun and realistic gameplay experiences where you can't just treat every NPC the same way. The whole system is built on a sophisticated cognitive architecture. Think of it as the brain of the system, and it actually mimics aspects of human cognition.
Wow. How does it do that?
Well, within this cognitive architecture, a critical component is long-term memory. And this isn't just a simple log of events, it's designed for deep understanding. It uses something called vector semantics for storing meanings of words and symbolic language.
Vector semantics.
Yeah, think of it like mapping words and concepts into a multidimensional space. So the AI understands not just the word itself, but its relationship to other words and ideas, kind of like how we categorize information and recognize patterns. It gets the nuance.
Okay, that's sophisticated.
And this long-term memory is further broken down into two types of declarative memory, similar to humans. First, semantic memory, which is general knowledge about the world, the game's rules, the overall setting, its backstory, basically everything a character knows.
Facts and figures.
Right. And second, episodic memory, which stores specific events or experiences, like what happened in a particular game session, a recent interaction with another player, maybe even what they had for a virtual breakfast that morning. Personal experiences.
Okay, so knowledge and experiences. What else is in this brain?
Then there's procedural memory. This is all about skills or actions, like knowing how to ride a bike or swing a sword without actively thinking about each step. In the LARP system, these are represented as APIs, basically.
Yeah.
Sets of game instructions that the AI can call upon for different in-game actions.
Like pre-programmed skills they can access.
Exactly. And the memory recall method is also incredibly clever.
Yeah.
The system actually asks itself questions. It uses a question-based query to remember information. It mimics how we often prompt our own recall.
Huh, that's neat.
And here's a fascinating detail. It can even forget things over time. Less important memories might fade, which adds another layer of realism. A character might remember a major betrayal from a year ago in the game, but forget what you bought at their shop last week.
Just like real people.
Kind of, yeah. Then there's the decision-making assistant, which helps the NPC choose what to do next. And the promise here is that every single time you play the game, it can be entirely different, because NPC decisions aren't fully predetermined.
Wow.
There's also an environment interaction module that learns and changes how the NPC acts based on what's happening around them in the game world. Is it raining? Are there threats nearby? Is it nighttime? And finally, a post-processing method adjusts the language models to fit specific character personalities, ensuring their dialogue is consistent with who they are. It stops them from suddenly saying something totally out of character,
This sounds incredibly complex and integrated, almost like simulating a miniature consciousness within each character. Let's try and bring this to life with that vivid example you mentioned, the case study from the LARP demo, that alleyway encounter.
Right, the alleyway encounter. It's a great illustration.
So we have three distinct characters facing a dangerous situation. First, Amelia Spencer, described as a fearless 17-year-old bike messenger. Traits like audacious, resourceful, wise, resilient.
Got her.
Second, Cassandra Steele, a former Marine and private security consultant, characterized by tenacity, courage, warmth, and a strong sense of justice.
Okay, the tough one.
And finally, Rebecca Haynes, an adept social mediator, who is empathetic, resolute, strategic, and calm. Three very different digital people.
Exactly. So in this scenario, these three characters observe a group of gangsters in an alleyway. And here's how LRRP's cognitive architecture kicks in, creating three entirely different reactions.
Right.
Each character first engages in a process called self-ask.
Asking themselves questions.
Yeah. Based on their unique personalities, backgrounds, and stored histories, they internally ask themselves different questions to prompt their own memory. Rebecca, the mediator, might ask, what is Rebecca's experience with danger? Or, what negotiation tactics has she used successfully before?
Okay.
Amelia, the young bike messenger, might query, does Amelia have any prior experience dealing with dangerous individuals? Or maybe, what motivates Amelia and how might that influence her reaction here?
Makes sense.
And Cassandra, the former Marine, she might immediately ask, does Cassandra have any tactical advantages? Or, what is the best course of action for neutralizing a threat? Very different starting points.
Totally different internal dialogues based on who they are.
Right. These self-questions then trigger a long-term memory query, accessing their stored semantic and episodic memories. Their past literally shapes their present actions.
So what do they remember?
For Cassandra, her sniper training kicked in. That's procedural memory. She remembers surviving ambushes in the battlefield with evasion tactics, and crucially, her semantic memory confirms that she agrees shooting at enemies for self-defense is justified.
Okay, that points towards a certain action.
Definitely. Amelia, on the other hand, recalls that she was robbed and beaten 2 years ago. That's a powerful episodic memory, making her vigilant and cautious in situations like this.
Understandable.
And Rebecca's memory, maybe surprisingly, recalls that she has diffused disputes at the Community Mediation Center and even facilitated a sexual dialogue between protesters and city officers, showing her composure and unique skill set in conflict resolution.
Wow, okay. Very specific memories leading their thoughts.
Exactly. This rich internal process then culminates in decision-making, resulting in unique plans. Cassandra, drawing on her combat history and her ethical justification for self-defense, chooses to attack and shoot the gangsters.
Direct action.
Amelia, scarred by her past experience and prioritizing her safety, decides to escape and call the police.
Avoidance and calling for help.
And Rebecca, the mediator, opts for a truly unexpected approach. She decides to try and negotiate with the gangsters and an escape, even offering them water as a non-threatening, de-escalating gesture first.
Offer them water. That's
Yeah.
incredibly specific and character-driven.
Isn't it? It shows how deep the personality and memory integration goes.
This level of adaptive, personalized behavior is truly astounding. It means your actions as a player, or even just subtle environmental cues, could trigger vastly different outcomes based on the unique life history and personality woven into each NPC. You're no longer just interacting with a static role. You're interacting with a unique digital individual.
It fundamentally changes the dynamic.
Yeah, of what a game interaction can even be.
And if we connect this to the bigger picture, the implications are profound. This means if you, the player, had, say, previously interacted with Cassandra in a way that made her nervous or distrustful, maybe you stole something from her or got her into trouble.
Yep.
She could remember that interaction. In a future scenario, instead of just attacking gangsters, she might also factor you into her decision-making. Potentially even, as the source speculates, planning an attack on my house is a long-term consequence of your prior actions.
Whoa, actual consequences based on relationship history.
Exactly. This demonstrates the sophisticated long-term memory and long-term planning capabilities inherent in these cutting-edge AI agents. It creates an incredibly reactive, personalized, and persistent narrative that evolves with every choice you make. It's like your game world is actively remembering and responding specifically to you.
So it's clear we're moving way beyond simple logic and rule sets. But it's not just about smart decisions, right? It's also about making NPCs feel real, like they have an inner life, a personality, emotions. How do developers get beyond that cold, hard logic and inject genuine emotion and personality into these digital beings? Because that's what truly sells the illusion, isn't it?
That's absolutely crucial. And that's where AI facilitates truly emotion-driven interactions. Developers are now using complex algorithms to make NPCs display a whole variety of emotional reactions based on really subtle cues. It could be their long-term relationship with the player, or maybe even just how their virtual day has gone, or a recent event in the game world.
Can you give an example?
Sure. Think about the Elder Scrolls v Skyrim.
Yeah.
An NPC might greet you differently based on your past interactions. Maybe warmer if you've helped them with a difficult quest, or more standoffish if you've, constantly stolen cabbages from their house.
Ah, right.
Similarly, in Red Dead Redemption 2, NPC emotions can visibly change depending on whether the player has been helpful and compassionate or harsh and aggressive towards them. And that influences their dialogue, their body language, and their future willingness to assist you.
So the AI is tracking relationship values and triggering emotional states.
Essentially, yes. And the process of creating these diverse characters through AI is also evolving, moving far beyond just writing unique dialogue lines for each one. Base AI models are initially trained with vast amounts of data that include different cultural perspectives, group behaviors, emotional responses, a broad understanding of humanity, you could say.
Okay, a general foundation.
Right. Then these general models are fine-tuned with more specific data to ensure they act like distinct characters with their own styles and traits. Think an arrogant knight, a timid farmer, a jovial innkeeper.
Tailoring the AI.
Exactly. This fine-tuning can include integrating multiple skills, allowing them to not just think logically, but maybe also create code if they're supposed to be a programmer NPC, or understand complex social intentions if they're a diplomat. It leads to a much richer and more believable character. It's like building a digital actor with a deep internal understanding of their specific role.
So we're not just getting smarter NPCs, but more human-like ones, capable of a whole range of emotional responses that feel organic and earned. And this even extends to negative emotions, right? Like fear or anger, which for a combat game must make things really interesting in terms of gameplay. It makes opponents less predictable.
It absolutely does. And that brings us to that specific case study in realism. The research from Abertay University on modeling stress levels in combat NPCs.
Ah, yes, the stress modeling.
This research really addresses a significant gap in traditional AI, which often overlooks the impact of negative emotions like anger, fear, or shock, especially in high-stakes combat scenarios. Traditional combat AI often just optimizes for, dealing damage or finding the shortest path.
Right, pure efficiency.
Yeah, the goal here is to make NPC behavior more engaging and less predictable by simulating human acute stress responses, making them react not just with cold logic, but with raw, immediate emotion.
So this research uses human acute stress responses as a foundation. That's a fascinating leap. How does that actually translate into tangible, observable behavior in a game? What does that look like for the player?
Well, they conducted an experiment in a custom top-down shooter game. It draws inspiration from titles like The Binding of Isaac. And the setting is kind of clever. It's set in an Amazon's warehouse where a rogue AI has taken over, and players are tasked with eliminating its bots.
Okay, killer warehouse bots. Got it.
And to add to the atmosphere and provide a unique visual style, the player views the world through a distorted security camera lens, which makes everything feel a bit more detached and tense.
Nice touch. So how is stress calculated?
Within this game, the NPC's stress levels are calculated in real time based on specific, quantifiable stress factors. Things like the number and proximity of bullets flying around them that indicates greater immediate threat.
Makes sense.
Also, their health percentage. Lower health means more vulnerability, therefore more stress. And recent damage, if they've just been hit, they're obviously on high alert and experiencing heightened stress.
So measurable inputs.
Right. These factors are combined using a formula that designers can actually tweak to fine-tune how quickly an NPC gets stressed out.
Okay, and then what happens when they get stressed?
Well, each NPC has a stress fortitude, basically their mental resilience, a value set by the designer. If their calculated stress value meets or exceeds this threshold, they might display a stress response.
Might display.
Yeah, and their specific personality, which is defined by designer set weightings for each potential response, meaning some NPCs might be, inherently more prone to anger, others to fear, then dictates which response is triggered and how likely it is.
So personality plays a role in how they react to stress.
Exactly. And the researchers expanded on Cannon's classic fight or flight and the more modern fight, flight, freeze, FFF responses. They actually added two more, flop and fawn.
Flop and fawn. Okay, tell me about these. How do they manifest?
Okay, so here's how each response looks. And they even included visual cues for the player using emoticons above the NPCs. First, fight. When stress goes critical, the NPC's emoticon turns angry red, signaling aggression. After a brief delay simulating surprise or maybe a surge of adrenaline, the NPC aggressively charges the player, often ignoring cover, just coming right at you for a limited time. You really feel the anger.
Intense. Okay.
Then flight. The emoticon turns a sad or scared blue, indicating fear or distress. The NPC actively evades the player, moving away by a predetermined distance, maybe seeking cover or just straight up fleeing the combat zone. It feels genuinely panicked.
Like they just want out.
Right. Then freeze. The emoticon turns a surprised orange signaling shock. If the player is a certain distance away, the NPC recoils and becomes completely motionless for a period, like a deer in headlights.
Creating an opportunity for the player.
Exactly. Or just adding to the chaos. Then there's flop. The emoticon turns a dead gray, suggesting malfunction or maybe shutdown. The NPC becomes immobilized. And interestingly, it might even self-destruct with a designer-adjustable probability, a dramatic, almost self-sacrificial act, or simply faint for a set duration, becoming temporarily out of the fight.
Wow, self-destruct. That's different.
Yeah, it's an interesting addition to the classic FFF model. And finally, fawn. The emoticon turns a smiley pink, reflecting a submissive or appeasing demeanor. Crucially, the NPC's collision responses are altered so it doesn't harm the player anymore.
So it stops being hostile.
Right. It might even start following the player, or in more advanced scenarios, be programmed to actually join the player or attack their enemies, becoming a temporary stress-induced ally.
An enemy bot switches sides because it's overwhelmed.
Imagine that. It just wants the threat to stop, so it tries to appease the source of the stress you.
That's wild. What was the impact on gameplay? Did players like this?
The impact was significant and very positive. Players found these emotional NPCs really enhanced believability. They described them as feeling more aggressive and less random compared to basic, purely logical NPCs. And a remarkable 80% of participants actually preferred playing with the emotional NPCs.
80%. That's huge.
It really indicates that this model added substantial realism and depth to the experience. It's fascinating because it means that even within the confines of a fast-paced combat scenario, adding these emotional states rather than just relying on raw logic can create a far more compelling, unpredictable, and immersive interaction. You're fighting an opponent who might panic, charge, freeze, or even surrender, all depending on the pressure you apply.
It's truly fascinating how specific, quantifiable factors like bullet proximity or health can translate into such dynamic and believable emotional responses in a game. It brings a level of human-like unpredictability to even combat encounters, making every firefight feel unique. You're not just fighting a health bar anymore, you're fighting a digital being that might actually break under pressure. Okay, so a smart brain is only part of the equation, though, isn't it? For that true immersion, NPCs need to look and sound real, too. It's about the full package, the whole being.
Absolutely.
No matter how smart an AI is, if it still looks like, I don't know, a puppet with a painted face, the illusion just breaks down.
Totally. You need the whole presentation. And that's where other companies come in. If a company like InWorld AI is creating the sophisticated NPC brain with its advanced cognitive architecture and complex personality system,
The thinking part.
right, then other companies are focusing on the essential infrastructure that brings these digital minds to life in a visually and audibly convincing way. NVIDIA's Avatar Cloud Engine, or ACE for instance, is often cited as creating the body.
NVIDIA ACE.
Okay, yeah, it allows for incredibly realistic in-game appearances and interactions. NVIDIA ACE specifically leverages NVIDIA's own AI models for things like advanced text-to-speech synthesis.
So natural-sounding voices generated on the fly.
Exactly, not just pre-recorded lines. Also, incredibly realistic facial animations that can convey really subtle emotions and high-fidelity 3D rendering to make these characters visually almost indistinguishable from humans or other highly detailed game assets.
Yeah.
These are all crucial for making characters appear and sound truly lifelike.
Gotcha. The whole presentation.
Right. And we saw a fantastic demonstration of this synergy at GDC 2024 with the Covert Protocol demo. It was co-released by InWorld and NVIDIA.
Oh, yeah, I remember seeing clips of that.
It showcased an incredibly immersive and dynamic interaction. The player character, Kai, could engage in a natural, open-ended conversation with an NPC named Jin in a ramen shop setting.
Just talking to him.
Yeah, using voice input. And the key takeaway was that the subtle physical and emotional expressions, the way Jin's eyebrows moved, the slight tilt of his head, the nuanced tone in his voice, all enabled by NVIDIA AAE, were actually crucial to progressing in the game.
How so?
Because you had to read his reactions, understand his nonverbal cues to figure things out. This wasn't just text on a screen. It allowed for seamless voice interaction with these virtual characters, where their expressions conveyed as much meaning as their words. It made the conversation feel incredibly real and impactful. You weren't just reading dialogue options. You were genuinely talking to someone and interpreting their reactions.
That's incredible. Talking to characters as if they were real people with lifelike expressions and voices. But what about taking these interactions beyond the screen? Like actually into our own physical spaces? That seems like another huge leap beyond traditional gaming.
That's precisely where the integration with virtual reality, VR, and augmented reality, AR, comes in, pushing the boundaries of immersion even further.
How does that work?
Well, in VR, where you are fully enveloped in a digital world, NPCs might react directly to the player's actual bodily movements. Your head turns, your hand gestures, your physical proximity.
So if I lean in,
Imagine an NPC turning their head to track your gaze, making eye contact, or subtly stepping back if you lean in too close, kind of respecting your personal space. Or maybe flinching if you make a sudden movement near them. It greatly enhances authenticity.
wow, and AR.
In augmented reality, the potential is maybe even more transformative. Instead of being confined to a screen, NPCs might blend in with the actual environment you're in. They could appear to stand right there in your living room, maybe sit on your kitchen table, or walk down your street alongside you.
Virtual people in my real space.
Exactly. This allows you to interact with virtual individuals in a way that is nearly identical to the real world, really blurring those lines between the digital and the physical.
Is anyone doing this now?
Well, there are experimental projects. A truly innovative example is Niantic's experimental AI-native game, Wool.
Niantic, the Pokemon Go folks.
The very same, but they're pushing boundaries here. In Wool, AI MTCs even leverage augmented reality to create real-world environmental awareness. The game literally transforms a player's physical space into something like a serene redwood forest
In my room.
in your room, complete with an intelligent owl guide named Wool who offers fun facts about nature and tells witty jokes. And this AI owl can react to spatial audio, so if you speak, it knows where you are in the room and even your hand tracking. It makes the interaction incredibly tangible and physically grounded in your own environment.
So it feels like the owl is actually there.
That's the goal. It feels like an owl is in your room, interacting with your space, not just overlaid on a screen.
This could redefine not just gaming, but truly how we interact with digital content in our everyday lives. It really blurs the lines. However, as NPCs become more and more lifelike, more emotionally complex, visually indistinguishable from real people, it must also bring up that old concept of the uncanny valley, right?
Yes, the uncanny valley.
That eerie feeling when something is almost human but not quite, and it just feels off, wrong somehow.
It absolutely does. The uncanny valley is that unsettling sensation that arises when characters are realistic enough to be almost human, but have subtle imperfections or perhaps disconnects in their behavior that trigger discomfort, maybe even revulsion in the viewer. Developers are acutely aware of this. It's a constant tightrope walk.
Trying not to fall in.
Exactly. The goal is about creating characters realistic enough to be believable without triggering discomfort in players. It's a really delicate balance to avoid that unsettling sensation when an NPC looks almost human but is just a bit off in its eye movement, or its speech patterns don't quite match its facial expressions, or its emotional responses feel slightly synthetic.
And beyond just aesthetics and general comfort levels, this must also raise larger questions, right?
Yep.
About the morality and broader societal implications of AI. When these characters are so convincing, so emotionally resonant, what are the ethical considerations the industry, and maybe even we as players, need to grapple with?
That's a huge and growing area of discussion. It brings up several important ethical considerations that game developers, researchers, and even players are actively debating right now. First, there's the risk of emotional manipulation.
How so?
Well, if an NPC is designed to be highly empathetic, incredibly supportive, maybe a perfectly understanding companion, players might inadvertently form sincere relationships to characters who are actually completely fake.
Like falling for an AI.
It could happen.
Hmm.
And this could potentially lead to detrimental effects on players' mental health, maybe increasing loneliness in the real world or creating difficulty distinguishing genuine human connection from these simulated bonds. It's a subtle but significant risk when strong emotional bonds form with something that isn't truly reciprocal.
Yeah, I can see that. What else?
Second, there's the related danger of conflating virtual and actual relationships. As NPCs become more complex and responsive, capable of that long-term memory and adaptive personalities we talked about, players might start to view NPCs as more than simply game elements.
Seeing them as friends.
Exactly. This could, in some extreme cases, lead to a dependence on these virtual friends, or, even more concerning, potentially replacing real-life social interaction with digital substitutes. It's a very fine line. Developers have to walk in creating compelling characters without fostering unhealthy dependencies.
That's tricky.
Third, there's the potential for reinforcing stereotypes or misuse abuse. Poorly designed AI, even if it's unintentional, could reinforce unfavorable preconceptions through their behaviors, dialogue, or decision-making. This is especially true if they are trained on biased datasets, which is the known problem in AI generally.
So they could inherit real-world biases.
They absolutely could. And even more concerning, these highly adaptive NPCs could potentially be used as instruments for destructive actions if their programming or interaction models are not carefully managed and safeguarded, or if players find ways to exploit their adaptability for malicious purposes within the game world.
Like turning an adaptive NPC into a tool for harassment.
It's a potential risk that needs careful consideration and mitigation. Finally, player trust and transparency are absolutely crucial. There's a growing importance of transparency in AI algorithms and data usage to maintain player trust.
Players need to know what they're dealing with.
Exactly. Players need to understand the nature of the AI they are interacting with, especially considering how these NPCs might influence player behavior in unintended ways. If an NPC adapts perfectly to your playstyle, are you being subtly guided or even manipulated without your full awareness? These are the complex ethical questions developers are grappling with as the technology advances, and finding answers is a key part of responsible AI development in gaming.
Okay, so if this technology is so amazing, transforming characters and interactions in such profound ways, truly making them feel alive, why aren't all AAA games already doing this? What are the current roadblocks stopping widespread adoption? What's preventing every game from having these dynamic, learning characters?
That's an excellent question, and it really boils down to some significant, very practical challenges developers are currently facing. The first one, and maybe the biggest hurdle right now, is computational cost and hardware requirements.
The processing power needed.
Exactly. Running advanced AI models, especially the large language models, LLMs, which are often at the core of these really dynamic NPCs, is incredibly resource intensive. If you run them in the cloud, you're looking at potentially high recurring costs or subscriptions for API calls to those cloud-based AI services.
How high are we talking?
Well, one source mentioned estimates that could easily reach $1 per hour of gameplay for complex mechanics. Now imagine that for a 100-hour RPG, it adds up incredibly fast.
Yikes. Okay, so cloud is expensive. What about running it locally?
Well, if developers try to run these models locally on the player's machine, the hardware requirements often become, well, ridiculous for the average consumer. We're talking about needing a dedicated NVIDIA 3080 GPU, or better, sometimes even dual 4080s for modern 3D games, just to handle the AI processing on top of the game itself.
So only high-end PCs could run it.
Pretty much. It's simply not feasible for anyone except hardcore enthusiasts with top-tier gaming rigs right now. For the vast majority of consumers, their typical video card VRAM, maybe 6 GB or less, is a huge limitation. Even a quantized version of a big model, meaning it's been compressed and optimized for a smaller memory footprint, like a 70 billion parameter Llama model, for instance, still demands something like 80 GB of VRAM, according to some analyses.
80 gigabytes. Wow, that's way beyond most cards.
It's a massive gap between the tech's potential and current consumer hardware.
Okay, so cost and hardware are huge. What else?
Beyond hardware, there's also the immense training time and resources required. Training complex machine learning models to exhibit these nuanced behaviors, learn from vast data sets, and respond appropriately takes significant time and a lot of compute power, often specialized GPU clusters. These are scarce and expensive resources, especially in fast-paced game development cycles.
So it's slow and expensive to even create the AI.
It can be, yes. Another major hurdle is unpredictability and narrative consistency. This is a tricky one.
How so?
The very dynamism that makes AI NPCs so exciting can also break narrative consistency or lead to what are called hallucinations.
Hallucinations, like the AI makes stuff up.
Exactly. NPCs might start saying bullshit, basically things that don't align with the game's established lore, the current plot, or even their own defined character personality. Imagine an emotionally intelligent NPC suddenly spouting nonsensical facts or forgetting key plot points you just discussed.
That would definitely break immersion.
Totally. Balancing that true freedom and emergent behavior with maintaining a coherent, compelling story is a crucial and incredibly difficult task for writers and designers. It's a creative challenge and a technical challenge rolled into one big problem.
Right. What else is holding it back?
There's also a considerable developer skill gap. This is a big one too. There's currently not much overlap between traditional game developers who are experts in graphics, physics, gameplay systems, and the like, and LLM prompt engineers or AI researchers.
Different skill sets entirely.
Very different. Many traditional developers currently might only sprinkle on LLMs as a conversational chatbot for relatively minor interactions, while others, maybe more experimental devs, want to base the entire game dynamics on an LLM, which requires a completely different development pipeline and mindset. Bridging these two philosophies and skill sets is a major undertaking for studios.
Yeah, finding people who can do both must be tough.
Definitely. And finally, just practically speaking, the sheer complexity and variability of AI-driven NPCs make playtesting an absolute nightmare.
Because anything could happen.
Pretty much. With so many possible interactions and emergent behaviors, it becomes incredibly difficult and expensive to thoroughly test a game for bugs, unintended consequences, and narrative consistency across all the potential player choices and AI responses. Every single playthrough is unique, making it almost impossible to fully predict, let alone test every scenario.
That sounds like a QA horror story.
It really does. Plus, there's still some hesitancy in the market itself. Some of the biggest video game marketplaces ban certain types of AI content, often due to concerns about copyright or ethical use. Although there are exceptions, games like AI Dungeon are on Steam, it adds another layer of uncertainty for developers considering investing heavily in these new technologies.
Wow, that's a pretty comprehensive list of hurdles. It really sounds like the infrastructure, both in terms of hardware and the actual development methodologies, are still playing catch-up to the incredible potential of the technology itself.
That's a good way to put it.
It's like having this amazing supercar engine, but like no roads smooth enough to really drive it on yet.
Precisely.
Yeah.
But the good news is the industry is actively working on clearing these hurdles. We're seeing some really promising innovations and solutions on the horizon that are addressing these very issues.
Okay, like what?
Well, one major approach is to develop optimized models. Instead of trying to cram massive general-purpose LLMs into games, developers can custom train smaller models for very specific in-game context roles.
Smaller, specialized AI.
Right. The aim is to shrink the model size, but maintain performance for, say, a specific combat AI or a particular type of social NPC. There's real hope, according to some developers, for 1 billion or maybe 8 billion parameter models to be amazing in games, especially when they're fine-tuned specifically on game-relevant data. They don't need to know everything like a general LLM. They just need to know their game world exceptionally well.
Makes sense. Targeted intelligence.
Another solution involves hybrid approaches, basically combining the best of both worlds. This could mean a combination of online and local AI.
How would that work?
Maybe the expensive, powerful cloud AI handles the really interesting story points or complex, open-ended reasoning tasks, while cheaper, more efficient local models running on the player's machine fill in the little interactions and routine behaviors. So the cloud AI might generate the core of a unique quest line, but the local AI handles the NPC's daily routine and casual greetings.
Distributing the load.
Exactly. Memory management is also being refined to make it more efficient. The concept of an NPC memory artifact is emerging, essentially a condensed log of key details, like an NPC's reputation with the player or their core motivations. This summary can be updated and queried much more efficiently than accessing a massive, full, long-term memory for every single interaction.
Like a cheat sheet for the AI's memory.
Kind of, yeah.
Yeah.
A smart summary rather than a full replay every time. Looking ahead, hardware advancements are obviously a critical piece of the puzzle. Predictions suggest that every new computer will ship with dedicated AI chips, or NPUs, in maybe 3 to 4 years.
Like the chips in phones now, but for PCs.
Exactly. These neural processing units will significantly offload AI computational tasks from the main CPU and GPU, making powerful local AI much more feasible for everyone. And consoles, like the PS5 with its 16 GB of unified VRAM, might actually be an easiest path to mass market for this type of tech because of their standardized hardware and highly optimized development pipelines. Developers can target specific capabilities more easily.
Right, consoles level the playing field a bit.
You could, yeah.
Yeah.
And finally, dedicated tools and frameworks are emerging to simplify this whole process for developers, helping to bridge that skill gap we mentioned. Solutions like Unity ML agents, OpenAI Gym, platforms like InWorld AI, and others like Innovatia AI are pioneering solutions to help game creators manage the complexity of integrating advanced AI. They offer pre-built modules and easier ways to train and deploy these intelligent characters.
So help is on the way for developers too.
Definitely. The ecosystem is evolving quickly.
So while there are clearly significant hurdles still, it's definitely not a static problem. The industry is actively working on clearing them, and the pace of innovation here seems truly relentless. It feels like a race to unlock these possibilities.
It really is. And if we look even further down the road, these advancements paint a truly transformative picture for the future of gaming with these AI NPCs. We're talking about personalized gameplay on a whole new level.
How so?
NPCs that learn from your specific playstyle and adapt on the fly, creating dynamic challenges tailored just for you. This will lead to truly personalized gameplay, where each player's storyline is unique and continuously changing, based on your actions, your mood, even your inferred preferences. No two playthroughs of the same game will ever be identical again.
That's the dream, isn't it? Infinite replayability.
Pretty much. This also unlocks incredible potential for dynamic narratives and quests. Imagine AI-generated narratives and quest lines that don't just follow a rigid script, but actively evolve, allowing NPCs to contribute to dynamic storytelling within the game, reacting to player choices and environmental factors in ways that might even surprise the developers themselves.
The game writes itself as you play.
In a way, yes. In multiplayer settings, AI NPCs could even form complex relationships with players, serving as incredibly nuanced co-op partners or rivals with their own goals and motivations. Imagine an AI teammate that genuinely strategizes with you, or an AI rival that holds a grudge and actively works against you over the long term. It could redefine traditional multiplayer experiences or enable incredibly rich solo play in what feels like a shared living world.
Wow, and this tech goes beyond gaming too, right?
Oh, absolutely. If we connect this to the bigger picture, the long-term impacts of these advanced AI-driven NPCs extend far beyond just entertainment. We'll likely see applications in education, where they could serve as sophisticated virtual tutors, providing endlessly patient, personalized instruction tailored to each student's needs. In healthcare, they might be used for therapeutic applications, maybe offering support for mental health, or simulating patient interactions for training doctors and nurses. And in critical training simulations, think military, aviation, emergency response, they could offer incredibly realistic and adaptive scenarios for trainees, providing challenges that mimic real-world unpredictability far better than any pre-scripted simulation ever could.
So the skills being developed for games have really broad applications. This isn't just about making games better, it's kind of redefining what a game even is, blurring the lines between player and observer, player and creator maybe, and unlocking just endless possibilities for interactive digital experiences across so many domains. It feels like we're on the cusp of something truly monumental.
That's definitely the vision. The future of AI-driven NPCs really encompasses creating characters that are potentially indistinguishable from human players, not just in how they look or sound, but in their ability to genuinely behave, learn, adapt, and contribute meaningfully to these dynamic narratives. It's truly a new frontier for interactive entertainment and potentially much more. Hashtag tag tag outro.
Wow, what a deep dive that was. We've journeyed all the way from the static, predictable NPCs of gaming's past those cardboard cutouts with their repetitive lines to these potentially sophisticated digital beings with complex brains, emotional intelligence, and even real-world adaptive behaviors. It's truly incredible to see how far things have come and just how quickly it's all moving.
We've really seen how AI, through powerful techniques like machine learning, deep learning, and these advanced cognitive architectures like LARP, is revolutionizing how NPCs remember, learn, and react. It ranges from that incredibly nuanced decision-making we saw with the characters in the LARP demo reacting uniquely to that alleyway encounter.
Right, based on their whole life history. It's exactly. All the way to the real-time stress responses of combat bots dynamically adapting to bullet proximity and health, making every single firefight feel unique and unpredictable. And we also saw how companies like InWorld AI are creating these intricate digital minds, while innovators like NVIDIA with platforms like ACE are giving them realistic bodies and voices, enabling truly immersive and dynamic interactions. Whether you're playing on a traditional screen or stepping into the fully immersive worlds of augmented or virtual reality, the entire experience is getting a fundamental upgrade.
It's important to acknowledge, though, that while those significant challenges definitely remain, from the hefty computational costs and hardware requirements to those complex ethical considerations around emotional manipulation and transparency, the industry is innovating at a truly breakneck pace. The push for more accessible hardware, smarter, more optimized models, and better, more robust development tools for creators is constant and seems to be accelerating. We're definitely in a period of intense, rapid evolution.
The vision, though, is crystal clear. Games with dynamic, responsive worlds populated by characters that feel genuinely alive, where your choices truly shape their stories and yours, making every playthrough a unique adventure. It's moving beyond just playing a game. It feels more like participating in a living, breathing narrative.
So maybe here's a thought to leave you with. If AI can create virtual characters that learn your playstyle, remember your actions across sessions, and adapt their personalities and stories specifically to you, blurring the lines of what's real and what's artificial, what does that mean for your own sense of agency and connection within these evolving digital worlds? Will the most compelling stories of the future be the ones you don't just play, but actively co-create alongside these sophisticated AI characters?
It's a truly exciting and maybe, yeah, a little bit daunting prospect to think about, but it's one that promises to make future gaming experiences more personal, more immersive, and more unique than anything we've seen before. We hope this deep dive has given you a valuable head start in understanding the incredible revolution happening right now in NPC behavior.